Now, there is a way to solve example 5 without using the quadratic formula. With that said, guys, you are going to have to know how to use quadratic formula, because I do expect you to use it as part of the course, and you do cover it as a topic in math, so it is going to be there. But I will show you a different method, and we'll end up with the same answer. First thing you have to do is to look at all your formulas which involve time. And if you go back to your formula sheet, and we look at those formulas which involve time, we have this one here, next to, and here. And they should also include the information that we have. So we don't know anything about V2, so we won't use that one. We have acceleration time, we have displacement there. So let's just go back. So what we would have, we do have this one, V2 equals V1 plus AT. So that involves time. We have this one here. And we have that one there. Now, if you notice here at the last two, we can't use these because that would take us back to using the quadratic formula, which is something you said that we wanted to avoid. So why go back in and start the whole process over again if all you want to do is avoid using quadratic formula? So these last two here, we know they would involve using quadratic formula because there's a squared term and a plane term. Whenever you see that, it's quadratic formula. So we're going to leave these two out. That means our only option is to try, highlight here a different color, is to use this formula here. And you can say, sure, no problem. I know V1, I know acceleration, I can solve for time. But what about V2 though? You don't know V2. And you can look through the list, guys, there isn't another formula to use, you're stuck with this one. Now, is there a way that you could find V2 though? If you knew V2, if you had a number to put in here, you would know this, know that, know the acceleration, you could find time. Now I got a note here that remember V2 will be negative. We'll come back to that. I just had that there as a reminder for you folks and for me, so don't forget to mention it. So we take away this part here. If you look through your formula list, the only formula you could use to allow you to find V2, the ending velocity, is here, because you know the displacement, you know the acceleration, you know V1. So in a nutshell, what are you going to do? We want to use this formula here because it would not involve the quadratic formula. In order to do that, we need to use this formula to find V2. When you find V2, you're going to put it back in up here. So if we start now, let's solve this for V2. So we're going to bring the V1 over. So V1 is going to go over there. So you have 2 times AD. It's negative V1, so remember it becomes positive, and it is squared. And V2 squared. So common errors, people would forget to remember that this is squared, and the sign on that. The acceleration, since the ball is going down, is negative. Sorry, the ball is going up, so the acceleration is 9.8. Displacement is 8 meters. Oops. Plus 30, and that's meters per second up. And V2 squared. Now if you work out this multiplication here, 2 times negative 9.8 times 8, I think that's, give me 1 second guys, I think it's 156. 2 times 9.8 times 8, 156.8, and it's negative. Plus 900. And remember, it's v2 squared. So you get 743.2. And that's going to equal v2 squared. Now, if this worked out to be a negative number here, you've done something wrong, because you cannot take the square root of a negative number. To get rid of the squared term, you have to take the square root. So square root of 743.2 . 743.2 square root 27.3. So that's what the ending velocity is. Well, sorry about that, guys. That was Miss Blackman calling, so remind her not to interrupt when I'm doing your lessons. Now, where were we? Okay, get your V2 here. And I had a note made up here so I wouldn't forget. Remember, V2 will be negative. Well, now what's up with that? Now, I gave a hint or two as I was going through. The acceleration here, what direction was that in? And what direction was the velocity of the ball thrown in? Both of these were thrown were up. If you look back to here, we said they were up. Right here. Now, if you reread the question, so you're catching the ball on the way down. Well, this ending velocity is when the ball is traveling down. So if you were writing this out, this would be 27.3 meters per second down. Now, we said all of our vectors, directions, had to be the same. So we need to change this to a negative. So what's happening, and I'll do it over here, is the ball is being thrown up at 30 meters per second. And as it starts to come back down, and it's caught on the way back down, well, it's traveling in the opposite direction. So it's a negative 27.3. So this is what we need to use here. So remember what we had said. We would find the V2 and put it back in up here. So you had V2 equals V1 plus AT. So V2 is negative 27.3. Our V1 is 30. Our acceleration is negative 9.8. And we're going to find time. Bring the 30 over. Negative 27.3. Subtract 30 equals negative 9.8 t. That's going to be negative 57.3 divided by negative 9.8. Now to solve for t, you divide both sides by 9.8, negative. And if you're remembering right, we've seen these numbers before. So 57.3 divided by 9.8 is 5.8 seconds. Remember, negatives cancel, leaves you with a positive. So here's your answer, 5.8 seconds. Highlight that too. If you want to color, I must well color it all. And if we look back here, some of these steps you'd seen these numbers, right? You had 900 subtract 156. You were taking the square root of 742.3. Well, that's the same back here. 743.2 square root. So what this step does is break the quadratic formula down into a couple of steps. So really you're doing it, but you don't realize you're doing it because you have to use more than one formula. So here's the situation you're in. You can either use quadratic formula or you're going to be forced to use two different equations. I'd rather use quadratic formula, and perhaps I'll get you guys to practice both, give you two questions, do one this way and one using quadratic formula.